Hi folks, today we're going to look at an efficiency and power example, continuation on in the conservation of energy and work unit. So let's take a look at this question. As usual, we'll highlight some information, put that together and see where we're going. So a large industrial motor is used to lift an 800 kilogram elevator to a height of 10 meters. If the motor has an efficiency of 80%, what is the required electrical energy input? And what is the power output of the motor if it takes 2 minutes? So we got 800 kilogram elevator. We know that's the mass of it. We got a height of 10 meters, and we have an efficiency of 80%. And we're looking for the electrical input, energy input. So let's take it tonight. Let's take a little sketch of this. So we've got a box. We're going to take that box that's sitting on the ground. Oops, sorry. The box is sitting on the ground, and this motor is going to lift it. So initially, the energy is 0, and then somewhere up here, the final position, the energy is gravitational. So we're looking for energy, electrical energy input. We've got an efficiency. So anytime you got an efficiency, probably the quickest way to get about this is look at the efficiency equation. And it says the energy out or the work out. So we're going to use energy out in this one because it's looking for energy in. So the energy out over the energy in times 100% gives you the efficiency. I'll jump down a little bit. Let's write down what we have for givens here. Mass is 800 kgs. Efficiency is 80%. And the height is 10 meters. So the energy in is what we're looking for. But we have to figure out what the energy output is. When I look at this, the energy, that should be energy equals 0. So initially it has the energy output is simply what type of energy exists at the final position. In this case, it's Eg. So let's just switch it right out right in the formula. So the energy output is this is our energy out. So I'm going to switch it right here. Eg over E in for energy in times 100%. The efficiency is 80%. Eg, replace me if you remember. Move to formula page. MGH over energy input times 100%. That 100% is going to make that work over there. Anytime I got my unknown in the denominator, these two have to switch. So my energy input is equal to mass, which is 800, times gravity, which is 9.8. Remember, it's positive in this section because they're all scalar values. The only section that needs a negative is the kinematic section. And the height is 10. And I'm going to divide that by 80. And then the whole thing gets times by 100. So when I do the math, crunch those numbers, and I should get here for a number, if I do the math, 9,800 joules. Just a quick look at it. The 80 and the 8 divide, that gives me a 10. 10 times 10 is 100. So that would be 980. And then another couple zeros. Gives me my answer. All right, perfect. We also need to look at the power output of the motor. And so we're looking at the power output. Power equals work divided by time. I didn't put the time down. The time is equal to 2 minutes. But we can't leave it that way, so we got to put it in seconds, so you know how to do that. 120 seconds, it's multiplied by 60, because 60 seconds in a minute. So power output, we got to use the work output. So the work output is the energy output that I get at the end. So again, it's the gravitational energy. So that would be, we're going to replace the work with Eg, and divide that by time. Work out equals gravitational. Put that over on the side so we know where that came from. So power equals mgh. If you like, you can do it off to the side and then substitute it in. It's totally up to you. Oh, time in there first. So power equals 800 times 9.8 times 10 divided by 120. So the power output should equal, if my math is correct, 653.3 watts. And I'm beginning to think maybe this isn't a large industrial motor. Anyway, that should be our answer. I'll just quickly drag over my type solution because I'd like to do that now. There's no way really to put it. Just run it through here. So the required energy output, or the required energy input is 98,000 joules, and the power output of the motor is 653.33 watts. Sorry, it's a little clutter. Again, if you have any questions, feel free to email me or pop in and ask questions or to give me a shout. Thanks.